आपका कोई ड्राई लैंड एग्रीकल्चर का कोई कोर्स हुआ होगा आज तक?
Yes, sir.
हुआ है? So you know something about watershed?
Yes, sir.
चलो ठीक है. Yeah, my name is Arun. Welcome to ICRISAT. अगले 1 घंटे में we will show you some of the research facilities and some of the demonstration crops. ये जो हमारे demonstration crop है, recently released varieties, and there are also certain varieties which are yet to be released. Okay, so live demonstration आप देख पाएंगे. तो उससे पहले I will give you some brief about what we are as an organization. Right? So ICRISAT stands for
International Crop Research.
तो उसमें 2 शब्दों का ध्यान देना चाहिए आपको, क्रॉप रिसर्च एंड सेमी
Semi-arid tropic.
तो सेमी एरिड ट्रॉपिक किसी को पता है व्हाट इज मेंट बाय सेमी एरिड ट्रॉपिक? एनीथिंग एल्स?
Cropping in drought area where water scarcity is.
Yeah, typical dryland crops, right? So as agriculture graduates, it is important for you to understand what exactly is semi-arid tropic. Okay, so semi-arid tropic is a very peculiar geography where the loss of moisture from evapotranspiration, that is loss of moisture from the plants, is more than the moisture we receive from rain for 6 to 8 months in a year. ठीक से समझ में नहीं आए तो आई विल गिव यू एन एग्जांपल. फॉर एग्जांपल, हैदराबाद इज ए टिपिकल सेमी एरिड ट्रॉपिकल क्लाइमेट. तो एनुअल रेनफॉल यहाँ पर होता है 850 मिलीमीटर. So technically speaking, 850 millimeter is lot of water. You can grow many crops, but there is a problem, and that problem is with the distribution. So what happens is, out of 850 millimeter annual rainfall, almost 80% occurs just about 4 months. June to September, we receive nearly 700 millimeters. Yeah? This has at least 3 very important implications as agriculture graduates. It's important for you to understand. Implication number 1, ये जो less than 200 millimeter rainfall है, distributed over 8 months in the year. हाँ? तो अगर करीब 700 मिलीमीटर 4 महीने में गिर सकता है, तो बाकी का 150 या फिर less than 200 millimeter spread over 8 months in the year. So it is not adequate for growing a second crop. Second, अभी सोचिए we are just at the beginning of summer and our daily average temperatures are already 35 degree plus. जैसे ही 12 बज के आगे जाएंगे तो it will be 35 plus degree Celsius. So hot and dry, this kind of temperature and direct scorching sunlight falling on the soil surface, right, causes soil health deterioration. There is a process called desiccation. Have you heard about it? Desiccation is literally drying up of your humus in the soil. So what is the function of humus? Organic carbon, उससे भी ज़्यादा. The primary function is holding moisture. It is literally like sponge in soil. It holds moisture, and then if the humus is dried up, there is no moisture, and if there is no moisture, there is no microbial activity. It makes soil a dead soil, right? And you cannot grow any crop in dead soil. So एक तो सेकंड क्रॉप पॉसिबल नहीं है, दूसरा सॉइल हेल्थ डिटीरियोरेट हो रहा है. तीसरा इम्प्लीकेशन, व्हेन द मानसून कम्स, द सॉइल्स आर नॉट रेडी. जैसे आपको 600-700 मिलीमीटर बारिश मिल सकता है 4 महीने के लिए, लेकिन द सॉइल्स आर नॉट रेडी. So apart from your normal tillage operations plus application of fertilizer, unless the farmers apply a lot of organic manure, so farmers cannot expect a decent crop yield. So this is the challenge. जो आप रेनफॉल के हिसाब से बता रहे हैं, just 700 millimeter rainfall, okay, that is a typical dry land. A dry land can be part of semi-arid tropic. Okay, so now semi-arid tropic, shorter rainy season, longer hot dry weather. Yeah, that is a larger problem not only in Hyderabad or India. globally there are about 55 countries which have semi-arid tropical climate. 55 countries. Geographically, it is 625 million square kilometers. That is close to 40% of the global geography. और आबादी के हिसाब से 210 crore people. That is nearly double the population of India. So many people are living in semi-arid tropics. 1 billion or 210 crore people. उनमें से about 75.5 million people, that is over 75.5 crore people are living below official poverty line. इसका मतलब lack of access to just one natural resource, that is water, can push so many people into poverty. So that is the larger challenge in semi-arid tropics, and that is where ICRISAT is trying to work by developing new crop varieties that are more suitable to these kind of challenging climatic conditions. Okay. So we are a crop research institute, and then we are doing research on crops to develop new varieties and hybrids. So crops, it is not n number of crops. We are specifically working on 6 crops. So 6 crops include 3 cereals, 2 pulses, and 1 oilseed crop. The 3 cereals are sorghum, jawar, bajra, और ragi. So sorghum crop का major crop हुआ करता था. I don't know if it is still major crop in Maharashtra. उनका बाकर, right? So sorghum, pearl millet, and finger millet, 3 cereals, and 2 pulses are chana और tur. Okay. So roti हो गया, जुड़का हो गया, and the only oil seed crop we are groundnut. So there are multiple crops being grown in semi-arid tropics, but why are we working only on these 6 crops? 2 simple reasons. One is these 6 crops are the major staple food crops found in most of the farming systems across the semi-arid tropics. You may say they are mostly common crops grown in semi-arid tropics. Second reason is this combination of cereals, pulses, and oil seeds completes your diet. Carbohydrates, protein, and vitamin combination. Okay. So these 6 crops apart, we are also working on the 5 minor millets. Just little millet, foxtail millet, barnyard millet, brown top millet, and koda millet. Okay. So though these 5 minor millets and 6 mandate crops put together across 11 crops. When we are working on them, we need something called basic facility, and that facility is called as gene bank. We have a gene bank on the campus. Okay. Gene bank is a place where we have collection of germ plasma from across the world. And the gene bank that we have here is meant for these 11 crops, and this is the largest collection of germ plasm in the world for these 11 crops. So the number of germ plasm we have on our gene bank is nearly 130,000, 8,30,000. 8,30,000 germ plasm across 11 crops collected from 144 countries around the world. And the highest number of germ plasm that we have is in your crop, sorghum. We have 42,000 plus germ plasm in sorghum alone, collected from 92 countries. उसका मतलब ज्वार सिर्फ महाराष्ट्र या फिर कर्नाटक में नहीं, दुनिया के 92 कंट्रीज में या तो कल्टिवेट होता है या फिर इट इज नेचुरली फॉर्म. So why you don't call them as varieties but call them as germ plasm is they are not only domesticated varieties but there are also wide relatives. So put together 42,000 plus germ plasm in sorghum alone. Now why do we collect them? It's not merely about collection and preservation. We do distribution. Distribution means these germ plasm can be availed or used by any research institute for research purpose free of cost from our gene bank. Okay. तो उससे भी बड़ा मतलब होता है, like when we work on development of varieties and hybrids, it is the germplasm which forms the basic breeding material for our breeders. Okay. Now every germplasm has one or the other unique characteristic traits, and it is those traits that we are interested in. So therefore, एक तो storage होता है, there also there is lot of time. How do you collect, preserve, yeah, and distribute? Plus, going forward, how do you store them for longer time? Storage maybe there are two different methods. One is called as short या medium term storage. Okay. So उसका मतलब the grains or germplasm that we collect both for long term and for short term or medium term. So जो दो methods होते हैं दोनों में they are stored as seeds, not as grains, because you have to maintain that viability, right? So how do you maintain them for short term and long term? The short या medium term में the grain or seed moisture percentage is brought below 8%, and they are stored in aluminum containers at 4 degrees Celsius temperature and 20% RF, relative humidity. Okay. So 10 से 15 साल तक आप उनको सेव कर सकते हैं, स्टोर कर सकते हैं without losing viability, and this is largely meant for our own research purpose regularly, plus also for sharing with other partners for research purpose, and also possibly with farmers if they are interested in growing this germplasm. Going forward, the long-term storage is done by packing these seeds after bringing their moisture percentage below 5, and then they are vacuum packed, okay, stored in pouches at minus 20 degrees Celsius temperature. So at that temperature, the humidity does not really matter because they are vacuum packed. Okay, so they are stored at minus 20 degrees Celsius temperature, and in this climatic conditions, you can actually store them for 40, 50 long years. It is literally like storing them for posterity. So the next generation farmers or scientists, if they want to use them, they are available with their viability intact. Okay. Now, a medium duration and long duration storage की बात हो गई, तो going forward, what the gene bank does on a regular basis, especially drawing seeds from short and medium duration storage, is the process is called as characterization. Yeah? So characterization is trying to find out the traits of each germplasm, and that has two different dimensions. One is phenotyping. Okay, phenotyping, you have heard about it?
Yes, yes.
What is phenotyping?
External character.
Yeah, it is not just morphological or physical appearance, but also physiological. How a germplasm or a plant responds to biotic and abiotic factors. Okay, this is put together called as phenotyping. The other process is genotyping. So identifying gene that is responsible for that unique trait in every germplasm. So इसके साथ साथ phenotyping and genotyping के साथ साथ there is also a process called as envirotyping. Basically, you are mapping the performance of a germplasm against a given set of weather parameters. So your daily average temperature, season, कितना बारिश होता है, relative humidity, a given geographical area, that particular weather in that particular area is mapped, and against that weather you develop varieties. Like if you want to develop a variety for Maharashtra, Rajasthan or Africa, so your variety should be able to respond well to those respective weather conditions. That is how. So development of a variety is invariably against the given agroclimatic condition for the geography for which we are developing these varieties. Okay, so that is what is done here. And then after you do genotyping and phenotyping, that data together gives insights to the breeders to develop new variety or hybrid according to market demand. Let's say a farmer wants high yielding sorghum, at the same time it is also tolerant or resistant to, let's say, this is smut. Now the traditionally available varieties may not have both the traits, and that is where the breeders will have to bring both the traits from different germplasm and then develop a new variety or hybrid. And that is the process of product development here. Okay, and it sounds very simple and logic. Germplasm में trait identify करो, combine करो, a new variety develop करो. That is logical and simple, but in practice it's very long, slow, uncertain process. Development of a new variety or hybrid takes anywhere from 8 to 15 long years. और 15 साल जाने के बाद भी हो सकता है you don't really come up with the best of the variety. That possibility is also there. Okay, so that is why a breeder will have to play with hundreds of promising breeding lines, so that eventually he goes on to develop one successful or maybe more than one successful variety or hybrid of the desired trait. Okay, so that is what is done on this campus, and accordingly on the campus this is supposed to be a global institute focused on semi-arid tropic research. Okay, from complete food value chain of dryland agriculture. We have research facilities here, and this is our headquarters. And this apart, we have 8 more offices in 8 African countries. 8 different African countries. They are spread out in West, East, North, and Southern Africa, rather Central and Southern Africa. So 8 offices in Africa plus this headquarters. We are working in the semi-arid tropics of Asia and Africa. Okay, and now this particular campus, which is a headquarters, okay, this complete area is 1,390 hectares. 1390 hectares. That is close to 3,500 acres. Yeah. Do you get a feel of how big it could be?
Yes, sir.
3,500 acres mane. If you simply walk around the periphery of this campus alone, it is 17 kilometers. Okay. Now, one of the very interesting features of this particular campus is, on this campus, out of 3,500, we have both alpizols and vertizols, red soil and black soil. 2 different soil types available on the same campus. This is a strategic advantage for us, and this was one of the important reasons why ICRISAT headquarters came to this particular place. Now crops like sorghum, pearl millet and chickpea, they prefer black soil. The other crops grow well in red soil. When you are working on crop improvement on these crops, it makes sense to grow them in the naturally preferred soil profile, right? So ICRISAT started in the year 1972. 2022 was our 50th year. By March 28, this month we are completing 50 years. Yeah? And then, so going with this crop research, lots of facilities are provided, and it is not merely crop research, although it says Crop Research Institute for Semi-Arid Tropics. Now when your focus is on dryland agriculture, apparently if you only work on crops, you are not likely to get full success. So the preconditions are you need healthy soil and moisture in the soil. Unless these 2 conditions are there, the best of the varieties or hybrids are unlikely to give any good benefits. Okay. Therefore, although we are called as Crop Research Institute, right from beginning, from inception, we have been working on soil health management and rainwater harvesting also as part of our 2 different crop research verticals. So soil health management, rainwater harvesting plus crop research, these are the 3 verticals. Okay. And from 72, when the institute started, the first 6 years have been spent in building the infrastructure for this global research institute. So infrastructure का मतलब not just buildings, roads, laboratories and offices. More importantly, how the land has been developed for undertaking crop research. So this used to be a barren, undulated land, and the entire campus has been subsequently developed into something called as precision farms. Okay, precision farm. The 1,390 hectare area has been subdivided into 6-hectare blocks. So every 6 hectare is a kind of precision farm, at least with 3 simple principles. One is they are of uniform soil color, uniform soil depth, and flat land. Yeah? It is not 100% flat, but there is a gradient maintained somewhere between 0.2 to 0.7 in order to allow drainage of excess water. When you get excessive rainfall or if you irrigate the field, you have to ensure the soils are saturated, moisture is distributed across the field uniformly, but at the same time when there is excess water, it has to be allowed to drain out of the farm without much of soil erosion. So that is where slight gradient is maintained. That's how right from land preparation, science and technology has been applied in developing this campus. Okay. Now coming back to some of the facilities that you can see from here before you start seeing the crops. So one, you can read out there what is written there. Yeah. Rain out shelter is basically a shelter to keep the rains out. But most of our experiments are around drought tolerance or germplasm that can give you best possible yield with minimum moisture. If you are trying to find out those traits and then you are doing experiments and then there is this unexpected rain likely to influence your crop research, you have to protect your experiments. So that shelter is meant for that. So you undertake research under this shelter, especially when you have doubts that there is unexpected rain likely to influence the crop research. So what they do there is they grow crops in pots and pipes. Crops like chickpea, groundnut, smaller root systems, they are grown in pots. And then crops like pigeon pea, pearl millet, sorghum, long tap root system, they are grown in long pipes, 1 meter, 1.5 meter, 2 meter PVC pipes with edge cap. And then, so when the rain occurs, assuming heavy rains, the soil is likely to get wet. But then these pots and pipes are isolating the crop from that external unwanted moisture. Okay, so that is how this shelter has been built, and you can also see small cranes there. Yes, what they do there is also like a couple of experiments, nutrition studies and root biomass studies. Like same germplasm or same crop, different germplasm, standard application of fertilizer to find out which of the germplasm has more vigorous root system. So if you want to do that kind of study, they do it under this shelter so that with crane you can literally lift the entire pipe along with the plant and then remove the end cap, wash it, and then you can separate plant along with complete root system intact, so that you can actually measure the length, girth, scan it, whatever test you want to do, you can do it. So that is the type of facility created there for root biomass study. And similarly, same crop, same germplasm, different nutrient doses to find out which is the most optimum. So how to minimize application of external nutrients. That's why study here the start. Now this facility, you can see there is netted area and you can see those blue trays there. Yes, sir. And there is a metal frame above. In fact, there are 4 white scanners. Yeah, at the other end, just behind, in front of that green small structure, if you observe, there are 4 scanners, yeah, fixed at a slight angle. They are facing the blue tray. Yeah, we have about 5,000 blue trays there. The entire facility is called as precision phenotyping facility. Right? So what they do there is like 5,000 trays. Every tray you can grow a different germplasm of the same crop. Right now they are growing groundnut there. So 5,000 trays, 5,000 different germplasm of groundnut. and each tray will have standard number of plants. For example, for groundnut, it is 8 plants per tray. That means 5,000 germplasm into 8 plants. That total plant population is 40,000. Now, those scanners, that metal frame moves from one end to the other end, and then by use of this digital technology, image processing, they take pictures and generate data on plant height, number of nodes, number of branches, leaf area, water use efficiency, about 20 to 25 different parameters. Okay, and 5,000 trays. To talk about 40,000 plants, every plant is measured and then data is generated. 40,000 plants in a matter of just 2 hours. Imagine if you were to do it manually, the number of skilled people you need, the time required, and despite that you are not able to avoid human error. Here it is a lot more accurate and quicker, and the entire data goes into cloud and it is available to breeders on the real-time basis. Okay. It even uses this artificial intelligence, like for every crop you are doing this scanning, you can configure the software, make a sit compatible, give us some water. Sit compatible. So it also gives you data on leaf angle relative to stem. So beyond certain angle, if the leaf is drooping, it is an indicator that the plant is asking for moisture. You can schedule immediately. That's how image processing and artificial intelligence are being used for crop research. Okay? So those two are the facilities. Now we have explained about how the crop research is done. Now in the last 50 years, what we have done is we have contributed the research to development and release of 1,144 different varieties and hybrids, 1184. And these 1,184 varieties and hybrids are released in 81 different countries. And that is not just restricted to Asia and Africa. Some of our crop varieties are also released in other continents like Australia, Canada. Yeah? So what now you can see is some of the recent varieties released or those which are under the pipeline. You can walk from this end to the other end until the boards are displayed. Don't get into the field, don't touch the crop or board, but then observe on the board. There is not only name or code of that variety, plus specific feature of that particular variety or hybrid. You can observe them, come back, and then we will continue discussion on why and what of those varieties. Okay. Any doubts, questions at this stage?
No, sir.